When 3I Atlas reached perihelion, something crossed that light, and something else came back. From the stillness between distant stars, an ancient traveler drifts into our solar system. Comet 3I Atlas moves with the quiet certainty of an object shaped across unthinkable distances, carrying the frozen memory of a sun that is not ours. It glides through the dark like a forgotten relic, carved by ages of silence and the slow breath of interstellar cold. For light years, it wandered untouched, holding secrets from a world forever hidden from human eyes. But as it drew near our sun, a subtle shift began. Its surface trembled, its gases stirred awake, and its entire form changed in ways no calculation had ever dared to predict. One scientist admitted, stunned by the data, "We cannot explain this with any known model. You can almost feel it as you listen." A lonely traveler entering the burning threshold of perihelion, where heat becomes revelation and the cosmos rewrites its own rules. There, in the brightest silence of all, 3I Atlas did not simply endure the light. It became something else. And now the question drifts through your mind, soft and persistent. What returned from the sun? If it was no longer the same, there is a certain quiet terror in losing sight of something that was never meant to be here in the first place. When Comet 3I Atlas slipped into the blinding brilliance of perihelion in late October 2025, humanity experienced a kind of cosmic blackout. It was not dramatic or loud. It did not unfold with alarms or frantic broadcast interruptions. Instead, the disappearance happened the way many profound things do in astronomy. Silently, in a wash of light so intense that even our finest instruments became useless. For a few brief days, the world saw nothing. Not a fragment, not a pixel, not even the faintest whisper of the interstellar traveler we had spent months chasing across the sky. It was as if the sun had inhaled it, as if the comet had stepped into a doorway of fire and simply chosen not to step out again. The moment 3I Atlas approached its closest point to the sun, the rules of observation collapsed. The comet entered a region so bright that it swallowed every attempt to track it. Telescopes from Hawaii to Chile, from the Canary Islands to Arizona, all fell into the same helpless state. Observatories switched their instruments to safety modes. Solar protection shutters closed. Automated systems flagged the object as lost, and for the first time in months, astronomers around the world had to accept a hard truth that went against everything they were trained for. They had to stop looking. One scientist at the Mauna Kea Observatory summed up the mood quietly, almost as if speaking too loudly might break something fragile. He said, "It feels like watching a door close on the universe and not knowing what waits on the other side." That sense of suspended uncertainty hung in the air. It wrapped around research teams, threading through labs lit by cold computer screens and half-finished coffee cups. People waited, not impatiently, but with the steady anxiety of those who know that nature does not owe them an explanation. The disappearance of 3I Atlas during perihelion was not unexpected. Every comet faces this moment when it plunges so close to the sun that observation becomes impossible. For a few days, the object is swallowed by solar glare. The light is so intense that it drowns even the brightest of tales. But with this comet, the uncertainty felt heavier. It carried the weight of distance, of mystery, of the simple fact that it did not belong to our system. A traveler from another star passing through our own, undergoing a transformation in a place where we could not witness it. And so the question lingered over the scientific community, like a thin veil. What was happening to it inside that furnace of radiation? We knew the physics. We knew the chemistry. We knew how comets behaved under extreme heating, but knowledge does not always satisfy curiosity, especially when the stakes involve an interstellar messenger that might only visit once in all of human history. In astronomy, light is truth. Light is information. Light is how we translate the cosmos into something we can understand. But for those few days, light became the very thing that denied us the truth. It was as if the sun itself insisted on privacy, refusing to let us witness whatever was unfolding in that glare. This moment, this sudden wall of blindness, revealed something about ourselves that we rarely admit. For all our telescopes, satellites, and instruments that reach into space with unwavering precision, we are still vulnerable to the simplest limitation. The brightness of our own star can still silence us. It can still blind us to the universe beyond. And in that blindness, we are reminded of how small we remain. Scientists filled the waiting days with theories. Some thought the comet might fragment due to thermal stress. Others predicted a sharp brightening. Others whispered cautiously about the possibility of unexpected behavior, the kind that defies traditional models. But no one could say anything with certainty. The data stream had gone dark. There was, however, another kind of silence, a quieter one, a reflective stillness that spread through observatories during those days, a sense that maybe disappearing into the sun is exactly the kind of theater an interstellar comet deserves, a moment of transformation so private, so shielded, that no human tool should be allowed to witness it. A researcher from Caltech remarked gently during a live stream discussion, "Sometimes the universe asks us to wait, not because it is withholding anything, but because the moment is not ours to see." This disappearance created a strange emotional landscape. On one hand, it felt like a cliffhanger in a story too large to grasp. On the other, it felt like a respect for cosmic timing. The comet was in the hands of the sun now, and whatever happened would be revealed in its own rhythm. And so humanity waited. Across time zones and continents, telescopes remained idle. Astronomers returned to their offices and stared at blank observation logs. The world went on, unaware that somewhere behind the glare of the sun, a fragment from another star was undergoing a transformation that might reshape our understanding of interstellar visitors. Perihelion is a crucible, a place where ice becomes vapor, where dust turns to plasma, where magnetic fields twist themselves into strange shapes. If 3I Atlas changed, it would change here. If it was damaged, the scars would be written in its tail. If it shed mass or broke apart, the evidence would trail behind it like the echo of a scream we never heard. But no one saw the moment of transformation. No one captured the flare or the fractures or the silent bloom of gases that may have erupted from its surface. For those hours, all we had was the blinding white of the sun and the waiting breath of a global scientific community. And yet, in that blindness, there was beauty. The beauty of not knowing. The beauty of anticipation. The beauty of acknowledging that even in the age of precision science, wonder still exists in the spaces where instruments fail. When the comet reappeared days later, the story took a startling turn. But before that revelation, there was only the silence of light, the humility of not seeing, and the quiet understanding that some cosmic events demand patience. In those days of planetary blindness, humanity remembered something important. The universe is not a sequence of answers, it is a sequence of moments. And some of those moments must be lived without clarity, held gently until the next piece of truth arrives. The disappearance of 3I Atlas was one of those moments. A pause in the narrative, a deep breath before the startling return, a reminder that not all mysteries are meant to be observed. Some are meant to be felt. Scientists filled the waiting days with theories. Some thought the comet might fragment due to thermal stress. Others predicted a sharp brightening. Others whispered cautiously about the possibility of unexpected behavior, the kind that defies traditional models. But no one could say anything with certainty. The data stream had gone dark. When the comet reappeared days later, the story took a startling turn. But before that revelation, there was only the silence of light, the humility of not seeing, and the quiet understanding that some cosmic events demand patience. And yet, in that blindness, there was beauty. The beauty of not knowing. The beauty of anticipation. The beauty of acknowledging that even in the age of precision science, wonder still exists in the spaces where instruments fail. For days, the world had lived in that strange suspension between knowledge and silence, watching the sun's blinding cradle like someone waiting outside a closed door with no idea what waits behind it. The disappearance of 3I Atlas during perihelion had left astronomy in a state of breathless uncertainty. We had lost the interstellar traveler to the brilliance of our star, and for a moment it felt as though the story might simply end there, swallowed by light and left to the imagination. On November 10, the Virtual Telescope project in Italy released the first new images of 3I Atlas after its encounter with the Sunday. What appeared on their screens was a vision so unexpected that it sent ripples across observatories and research centers around the globe. The comet's tail had transformed into a sweeping, spiraling structure of blue ion light. It curled and twisted with a delicate complexity that looked almost alive, like a ribbon drawn through water, shimmering in an unseen current. This was not the placid, pale tail the world had tracked before perihelion. This was something sharper, more intense, more charged with energy. It carried the color of ionized gas, glowing under the relentless pressure of solar radiation, a luminous signature of change. And yet, the shape itself seemed to speak of a deeper mystery. It was narrower, more defined, almost sculpted, as if the sun had carved the comet into a new form. In a quiet press briefing that same day, one researcher at the European Southern Observatory looked at the images on a large screen and finally said the words many were thinking: "This is no longer the same object we were tracking before." It was not exaggeration. It was observation. It was recognition. Something had happened inside the furnace of perihelion. Something too intense, too fast, too shielded by light for any telescope to witness directly. But the aftermath was unmistakable. To understand why scientists reacted with such disbelief, you have to imagine what they expected to see. Comets are chaotic, but they follow patterns. When they approach the sun, they brighten, shed material, release jets of gas, sometimes fracture. But even within this chaos, there is consistency. Their tails tend to behave in predictable ways, responding to the solar wind and radiation pressure with familiar geometry. But the blue ion tail of 3I Atlas told a different story. Its spiraling shape suggested a sudden, forceful release of matter, the kind that might happen during fragmentation or rapid surface collapse. Its color suggested an unusually high amount of ionized gas, far beyond the levels predicted for an object of its size. Its intensity suggested a massive surge of activity, as if the comet had woken from a deep slumber with a burst of energy that defied expectation. And so the questions began. What happened inside those hours we could not see? What force could reshape an interstellar comet with such dramatic precision? What did the comet lose or gain in its passage through that crucible of solar radiation? The return of 3I Atlas did not simply restore our ability to observe it. It deepened the mystery. The comet emerged like a survivor stepping out of a storm, carrying marks of a struggle no one had witnessed. One astronomer from MIT described the feeling during an interview. He leaned forward, almost whispering, as if trying not to disturb the fragile sense of wonder around the event. We were prepared to resume our observations. We were not prepared for this. In a way, this moment felt like the natural continuation of the story that began in Chapter 2. The comet's disappearance had created a silence dense with possibility. Now, its reappearance filled that silence with a new kind of uncertainty. Not fear, but fascination. Not confusion, but a deepening of the cosmic riddle. Because here is the truth. The blue ion tail was not just beautiful, it was improbable. It suggested that the comet had undergone a transformation so rapid that it challenged traditional models of cometary physics. Some speculated that perihelion had triggered volatile layers buried deep within the nucleus. Others wondered whether the comet had fractured internally, exposing fresh material that reacted violently with solar radiation. And then there were the more daring hypotheses, suggesting interactions with magnetic fields strong enough to twist the ion tail into its spiraling form. Whatever the cause, the result was the same. The comet that reappeared on November 10 was not the same traveler that entered the sun's halo a few days earlier. The change felt almost symbolic, as if 3I Atlas had crossed a threshold not meant to leave an object unchanged, as if the sun itself had rewritten a chapter of the comet's journey. For viewers watching the images online, the comet's new form looked almost poetic. Its spiraling blue trail resembled the stroke of a painter's brush, a ribbon drifting through the blackness of space, illuminated by a light it had survived. But for scientists, that beauty carried a challenge. It demanded explanation. The Virtual Telescope Project noted in their report that the structure of the tail appeared to fluctuate rapidly from image to image, suggesting dynamic processes at play. A researcher at NASA reviewed the images and remarked, "We need to understand what kind of energy release could sculpt a tail like that. This isn't typical behavior." And yet, in the midst of all the analysis, there was a sense of awe. The kind of awe that reminds us why people devote their lives to studying the universe. Not because everything makes sense, but because sometimes something refuses to. The reappearance of 3I Atlas was a reminder that the cosmos still contains events that resist immediate explanation. It was a lesson in humility, a whisper from the universe saying that even with all our tools, all our models, all our equations, we still stand at the beginning of understanding interstellar visitors. On November 10, humanity saw a comet reborn, a traveler reshaped by the Sunday. A mystery deepened, not solved, and as the images spread across the world, one question rose gently through the collective imagination. If this was the result of a few hours of hidden transformation, what else might be waiting in the chapters still unwritten? 3I Atlas had returned, but it had not returned unchanged. It had returned transformed, a message in motion, written in blue light across the dark. The return of 3I Atlas, with its spiraling blue ion tail, had shaken the scientific world. People stared at the images from November 10 with a sense of revelation, as if they were witnessing a shape the universe had kept hidden until the very last moment. And in the days that followed, as astronomers traded theories and compared models, a new realization began to surface like a quiet ripple beneath the excitement. Perhaps the transformation was not only in the comet, perhaps part of the mystery was in us, or more precisely, in the angle from which we had tried to watch it. That is where the story of its reappearance folds naturally into the next chapter. Because once the first thrill settled, scientists turned their attention to something subtler, something geometric, almost deceptively simple. They began to ask not just what had changed in the comet, but what had changed in our line of sight. This is where Chapter 4 begins. Many people imagine that when we lose sight of a comet, it is because it has dimmed or broken apart. But the universe often hides things not by reducing them, but by positioning them in ways that make us look wrong. The case of 3I Atlas was a reminder of this quiet truth. When the Virtual Telescope Project released the post-perihelion images, experts noticed something familiar beneath the novelty. The blue ion tail, dramatic as it was, pointed directly away from the Sunday, and as the images spread across the world, one question rose gently through the collective imagination. If this was the result of a few hours of hidden transformation, what else might be waiting in the chapters still unwritten? But the geometry of that simple rule had a surprising consequence. During perihelion, as 3I Atlas dove inward toward the sun, the ion tail was pointing almost perfectly away from Earth. We were standing behind the source of illumination. The comet's brightest feature was aimed in the opposite direction, hidden behind its dusty coma, folded behind layers of material thrown off in the heat of the Sunday. So while scientists watched the comet vanish into the glare, the tail was never gone. It was only invisible from our vantage point. A professor from the University of Arizona explained it with quiet clarity at a conference. He touched a simulation on the screen showing the angle of Earth relative to the sun and the comet's trajectory, then said, "We weren't looking at an empty sky, we were just looking from the wrong side." It was so simple that it felt profound. This geometric paradox, this trick of celestial alignment, was the key to unlocking the seeming metamorphosis that shocked the world. Before perihelion, we saw the comet with its usual dusty form, its soft glow, its gentle tail trailing behind. During perihelion, we saw nothing at all, and after perihelion, as the comet swung around the sun and the angle shifted, the tail that had been hidden suddenly swung into view. Not because it was new, but because now we were in the right place to see it. That shift in perspective changed everything. Imagine standing in a forest and watching sunlight pass through a spiderweb. From one angle, it is invisible. Move just 2 steps to the side, and the entire web erupts in color, shimmering with dew like a net of tiny stars. The web didn't become beautiful. You just entered the position where beauty was revealed. 3. Eye Atlas behaved the same way. While the spiral shape of the ion tail did reflect genuine activity and possible internal changes, a large part of its breathtaking appearance was revealed only because the comet's orbit rotated it into the right orientation relative to Earth. As it slipped around the sun and the geometry shifted, the hidden features emerged slowly, turning the blue tail toward us, like a stage curtain pulling back. To the world, it looked like a sudden transformation. But to the physics of the solar wind, it was simply the natural choreography of light and motion. This realization was humbling for scientists. They had spent days studying the post-perihelion images, as if the comet had dramatically changed, only to recognize that part of the story was an illusion of angle. It was not a deception, but a reminder that space does not present its truths in straight lines. We observe from one vantage point, and from that single vantage point we try to imagine a 3-dimensional, dynamic world. Sometimes we succeed. Often we misinterpret. A researcher at the Max Planck Institute tried to articulate this in a discussion panel. He gestured at a model showing the comet's orientation and said, "It wasn't a supernatural metamorphosis, it was a perspective trap. The universe patiently waited for us to move into the right position." This is the quiet wisdom hidden inside Chapter 4. The beauty of the cosmos is not always in the events themselves, but in the angles from which we witness them. The spiral tail of 3I Atlas was there all along, swirling in the solar wind, alive with particles stripped from the comet's surface. But until the comet completed its curve around the sun, those features remained tucked behind its dusty veil, concealed from our eyes like a secret, waiting for the right moment to be spoken. And when that moment came, it felt like revelation. The tail unfurled like a ribbon of blue fire. The patterns emerged in twisting arcs, delicate as silk. The comet seemed reborn, but the truth was quieter. The truth was geometry. This perspective shift did not lessen the mystery of 3I Atlas. In many ways, it deepened it. Scientists now had to untangle which parts of the comet's dramatic reappearance were true physical changes, and which were simply changes in how Earth was positioned to observe it. But there was a deeper, almost philosophical note beneath the analysis. The event reminded us that human understanding is always partial. We are beings on a small planet, orbiting a single star, looking outward with tools that can only face one direction at a time. When we lose sight of something in the cosmos, it is not always because that thing has disappeared. Sometimes, the Earth has merely rotated a little, or the alignment has shifted, or the light has turned in a way that blinds us. And then when we return to the right angle, the universe reveals that it has been continuing its dance without interruption. 3I Atlas showed us that even an interstellar comet, rare as it is, can teach a lesson older than astronomy itself. That truth depends on where you stand. That perspective can hide as much as it reveals. That sometimes the cosmos waits for us to adjust our gaze. When the comet's tail finally swung into view, it felt like the lifting of a veil. Not because the comet had awakened, but because the angle had shifted into harmony with our line of sight. And in that alignment, a mystery that seemed supernatural became a reminder of the elegant geometry that governs the motions of the universe. What looked like a metamorphosis was, in part, a matter of perspective. And yet, knowing that does not make the moment any less extraordinary. If anything, it makes it more wondrous, because it shows that even in the vast silence of space, revelation often comes not from change, but from finally seeing clearly what was always there. In the days after the geometric puzzle of perspective was finally understood, scientists felt a sense of relief. At last, one piece of the mystery surrounding 3I Atlas had a clean, elegant explanation. The spiraling tail that had stunned the world was partly a trick of alignment, partly a glimpse of the comet's true behavior finally turning toward us. It was comforting, almost grounding, to see how the universe could reveal its secrets through simple shifts in angle. But that comfort did not last long, because once the excitement settled and the data streams became steady again, astronomers began to notice something else hiding in the numbers. something that could not be explained by geometry or perspective, something that did not fit the familiar laws written into every model of comet behavior. And that is where the story of Chapter 5 begins. While telescopes around the world resumed tracking the comet, they began collecting its brightness measurements, comparing each new observation with predictions made months earlier. Comets brighten as they approach the sun, yes, but they follow patterns many decades of studies have taught us to expect. Even interstellar visitors, rare as they are, should obey the basic physics of sublimation and solar heating. Yet 3I Atlas refused to stay within those lines. Within days of emerging from the sun's glare, the comet's brightness surged to levels so intense that computer models had to be rescaled just to plot the data. It did not brighten by 10% or 50%. It brightened by a factor of 180, an increase so dramatic that it forced researchers to triple-check their instruments. A scientist at the Lowell Observatory stared at the numbers for several minutes before speaking. Finally, he said, "This is not following any law we know." It was not poetic. It was not dramatic. It was simply true. Brightness in comets is tied to the release of gas and dust from their surfaces, but the amount of energy required to produce a 180-fold surge pushed far beyond normal expectations. For a typical comet, this would signal a catastrophic breakup or an extreme outburst event. Yet 3I Atlas showed no clear signs of fragmentation. Its nucleus, though hidden within its glowing envelope, appeared intact. Something else had caused this explosion of light. Scientists turned to spectroscopy to understand more. If brightness could be deceiving, spectral lines could not. They reveal the elemental fingerprints inside the comet's tail, the chemical signatures that light cannot hide. When the spectral graphs came in, they showed a shift toward deep blue wavelengths, far more intense than before perihelion. Ionized gases were being expelled in enormous quantities, glowing with a color that suggested higher energy processes than typical cometary activity. It was as if the sun had reached into the comet and awakened something long dormant, something ancient, preserved in the ice since the comet left its home star, something that reacted violently when exposed to solar heat for the first time in millions, perhaps billions, of years. This was no ordinary brightening. It was an eruption of identity. One researcher at NASA's Goddard Space Flight Center described it with a kind of reverent disbelief during an interview. "The spectrum looks like it is shouting," she said. "It is telling us there is more happening inside this nucleus than we imagined." And indeed, the numbers were not cooperating. Outgassing rates soared well beyond predicted values. The ratio of ionized carbon compounds suggested deeper, richer layers were being exposed. The comet was releasing material at a rate that no standard sublimation model could justify. Scientists rechecked their thermal equations, their assumptions about density, porosity, even the mechanical strength of the nucleus. Nothing fit. And so, quietly, a shift began to take place in the scientific community. What started as a question of brightness became a question of composition, of structure, of origin. The comet's intense ion glow was not just a spectacle. It was a clue, a trace left by processes that were not aligning with patterns expected of typical comets formed around ordinary stars. Some wondered if the comet contained unusually high levels of super-volatile compounds, materials that vaporize at extremely low temperatures and could erupt explosively when warmed. Others suggested internal cavities might have collapsed, releasing buried ices all at once. Still others speculated whether the comet had been struck by solar storms stronger than expected, triggering accelerated ionization. But none of these theories fully explained the magnitude of the brightening. To cross the threshold of a 180-fold increase required a mechanism beyond what was familiar. The comet was behaving like a reservoir of ancient energy suddenly uncorked, which led some scientists to ask a more unsettling question. What if this behavior was not abnormal for interstellar comets at all? What if the problem was that our models were shaped by the comets in our own solar system, not by the landscapes of other stars? What if 3I Atlas carried within it the chemical memory of an alien sun, forged under conditions completely unlike our own? If so, its brightness was not a mystery, it was a message. The comet was announcing, in the language of light, that it came from a place with different rules, a place where ices accumulated differently, where chemical abundances followed unfamiliar patterns, where heat and pressure shaped bodies in ways our local experience cannot predict. The blue shift in its spectrum, far from being an anomaly, might be a signature of its origin, a clue to the environment in which it formed, preserved across interstellar distances until the moment it met our Sunday. But even with these possibilities, one truth remained. The numbers were still wrong. The models still failed. And science, for all its instruments and precision, found itself humbled once again. A physicist at the University of Chicago summarized the mood during a roundtable discussion. Looking at the data projected before him, he simply said, "When the universe gives you numbers that do not fit, you do not correct the universe. You correct the model." This was the heart of Chapter 5, the moment when nature pressed a firm finger against the limits of our understanding and whispered that even the familiar laws of light could bend under the right conditions. The brightness of 3I Atlas was not just a measurement, it was a disruption. A reminder that interstellar objects do not owe us predictability. They are guests from places we have never seen, carrying stories written in chemical languages we are only beginning to decipher. As the comet continued its journey outward, the blue glow of its ion tail trailing behind like a vow, scientists realized they were no longer observing a simple visitor. They were witnessing an argument between expectation and reality, between models built on Earth and truths forged around another star. And in that widening gap, filled with numbers that refused to obey, the mystery of 3I Atlas deepened. Not as a puzzle to be solved quickly, but as a question that would follow humanity long after the comet faded back into the dark. The mystery of 3I Atlas had deepened in ways no one expected. Its brightness had surged far beyond prediction. Its spectrum had shifted into a voice of ionized blue, and the numbers refused to settle into familiar patterns. It was as if the comet had carried the memory of another star and released it into our sunlight, leaving scientists with equations that bent under the weight of something they could not yet name. But brightness and spectrum were only the beginning. After weeks of careful observation, astronomers began to notice something even stranger, something quieter, something almost eerie in its subtlety. Not in the light this time, but in the motion. It was a discovery that did not arrive as a dramatic revelation, but as a whisper from the data, a small discrepancy that grew larger the closer scientists examined it. And that is where the story flows naturally into Chapter 6. When astronomers recalculated the comet's trajectory post-perihelion, they expected it to follow a path determined entirely by gravity. Comets, planets, spacecraft, dust grains, everything in space bends to gravity's rule, unless acted on by another force. For nearly every object we track, those calculations hold perfectly. But 3I Atlas refused to follow the clean curve predicted by celestial mechanics. Astronomers often say the universe speaks through numbers. Here, the numbers were telling a story of an object shedding its layers in silence, adjusting its path with every burst of gas, rewriting its destiny with the faintest of pushes. If the comet had been this reactive, this unstable beneath its surface, it meant the internal makeup of 3I Atlas might be fundamentally different from comets formed in our own star system. It might contain ices we rarely see. It might have been shaped in an environment with colder temperatures or different chemical abundances. Its structure may have been more fragile, more porous, or more volatile than anything we are used to studying. This explanation works for most comets, but 3I Atlas was not most comets. As teams across the world fed new data into their models, the numbers pointed to something startling. If the calculations were correct, the comet had lost between 10 and 13% of its total mass in just a few weeks. That level of mass shedding was enormous, far beyond typical activity. To lose that much material in such a short time would have required intense internal venting or large-scale structural collapse. When one physicist at JPL saw the results projected on a conference room screen, he leaned back slowly and said, "If this is right, the comet didn't just outgas, it detonated from the inside." Another researcher reviewing the data later added, "This is too much for normal sublimation. something extraordinary happened. As teams across the world fed new data into their models, the numbers pointed to something startling. If the calculations were correct, the comet had lost between 10 and 13% of its total mass in just a few weeks. That level of mass shedding was enormous, far beyond typical activity. To lose that much material in such a short time would have required intense internal venting or large-scale structural collapse. This explanation works for most comets, but 3I Atlas was not most comets. The phrase silent explosion became a way some astronomers described it. Not an explosion in the violent sense, but a release of energy that had been locked within the nucleus for ages, perhaps since the comet first formed in the outer reaches of its home star system. It was as if perihelion acted like a key turning in an ancient lock, releasing trapped volatiles that had been waiting across interstellar distances. For the moment, they would feel the heat of a new Sunday. But what was truly remarkable was not just the physical event, but the timing of it. The mass loss, the non-gravitational acceleration, and the altered brightness all overlapped within the same narrow window. These were not separate events. They were connected. They were the fingerprints of a deeper process unfolding inside the comet, a process that science is only beginning to decipher. The questions soon multiplied. What internal structures had collapsed? What volatiles were buried deep enough to erupt only under extreme conditions? How porous was the core? Did its interstellar origin give it characteristics unlike any comet native to our solar system? At a symposium held weeks later, a professor from the University of Cambridge summarized the situation in a quiet but firm voice. The orbital deviation is not a mistake, it is a signal. And that signal tells us the comet experienced substantial internal change. His words were met with an unusual stillness, because everyone in the room knew what it meant. The comet had not simply endured perihelion, it had been transformed by it. To lose more than 10% of its mass so quickly suggested that the comet had undergone something akin to internal restructuring. Large pockets of gas may have burst open, cavities might have collapsed. Ancient layers of super volatile ices could have flashed into vapor the moment sunlight reached them. These processes were not unheard of, but the scale here was unprecedented. This invisible force, this gentle but relentless push, reshaped the orbit of 3I Atlas, and in doing so, it reshaped our understanding of what interstellar comets can be. If the comet had been this reactive, this unstable beneath its surface, it meant the internal makeup of 3I Atlas might be fundamentally different from comets formed in our own star system. It might contain ices we rarely see. It might have been shaped in an environment with colder temperatures or different chemical abundances. Its structure may have been more fragile, more porous, or more volatile than anything we are used to studying. If the comet had been this reactive, this unstable beneath its surface, it meant the internal makeup of 3I Atlas might be fundamentally different from comets formed in our own star system. It might contain ices we rarely see. It might have been shaped in an environment with colder temperatures or different chemical abundances. Its structure may have been more fragile, more porous, or more volatile than anything we are used to studying. Astronomers often say the universe speaks through numbers. Here, the numbers were telling a story of an object shedding its layers in silence, adjusting its path with every burst of gas, rewriting its destiny with the faintest of pushes. A researcher at the Harvard-Smithsonian Center for Astrophysics captured it perfectly when she said, "The comet is steering itself with the pieces it is losing." That image resonated deeply. A traveler crossing interstellar darkness, shedding memories of its origin as it swings around a foreign star. Each cloud of gas, a page torn from its history. Each shift in trajectory, a consequence of letting go. The idea of a silent explosion is perhaps the most poetic way to describe it. Not a violent outburst, but an ancient echo unfolding slowly, invisibly, imparting motion with the debris of its own transformation. The comet was not fighting against the sun's heat. It was responding to it, releasing everything it had held locked for millions of years. Not just icy wanderers, not just luminous streaks, but dynamic, evolving, volatile travelers carrying the physics of another world. The questions soon multiplied. What internal structures had collapsed? What volatiles were buried deep enough to erupt only under extreme conditions? How porous was the core? Did its interstellar origin give it characteristics unlike any comet native to our solar system? And through their silent motions, they tell us stories written long before our sun began to shine. The discovery of the comet's non-gravitational acceleration unsettled the community, in a way few events do. Numbers tend to calm scientists. They anchor theories, correct mistakes, tighten uncertainty, but the numbers emerging from 3I Atlas did the opposite. This invisible force, this gentle but relentless push, reshaped the orbit of 3I Atlas, and in doing so, it reshaped our understanding of what interstellar comets can be. It was a revelation that left astronomers staring at graphs in dim offices long after midnight, running simulations that never quite matched reality. Yet even as the scientific world struggled to understand the implications, another shift was quietly forming beneath the surface. For wherever there is an unexplained phenomenon, there is also debate. And debate, especially in science, is rarely gentle. It is passionate, sharp, relentless, and fueled by the belief that truth is worth arguing for. That is the thread that leads naturally into Chapter 7. His statements spread across scientific forums almost instantly. Some embraced it, finding validation in his confidence. Others recoiled, pointing out that extraordinary claims require extraordinary evidence, and that the numbers emerging from telescopes were far from settled. Another group, equally committed to scientific rigor, insisted the data was being misinterpreted, influenced by errors in observation or flawed assumptions. The debate ignited quickly. Among the first to voice a bold interpretation was Professor Avi Loeb, known for his willingness to explore unconventional explanations when the data demands it. In a televised interview, he said, "This event falls outside the standard framework of cometary physics. We need to be open to possibilities we have not considered before." End of sex. His statement spread across scientific forums almost instantly. Some embraced it, finding validation in his confidence. Others recoiled, pointing out that extraordinary claims require extraordinary evidence, and that the numbers emerging from telescopes were far from settled. It was a revelation that left astronomers staring at graphs in dim offices long after midnight, running simulations that never quite matched reality. Yet even as the scientific world struggled to understand the implications, another shift was quietly forming beneath the surface. For wherever there is an unexplained phenomenon, there is also debate. And debate, especially in science, is rarely gentle. It is passionate, sharp, relentless, and fueled by the belief that truth is worth arguing for. A researcher from Caltech commented during a panel discussion, "Before we rewrite physics, we should double-check the math." Another scientist from the European Southern Observatory countered with equal conviction, "We have double-checked, we have triple-checked, the anomaly is real." And so the intellectual tug-of-war intensified. Another scientist from the European Southern Observatory countered with equal conviction, "We have double-checked, we have triple-checked, the anomaly is real." His statements spread across scientific forums almost instantly. Some embraced it, finding validation in his confidence. Others recoiled, pointing out that extraordinary claims require extraordinary evidence, and that the numbers emerging from telescopes were far from settled. And so the intellectual tug-of-war intensified. Rare too to see scientists argue so openly, driven not by rivalry, but by the urgency of a mystery unfolding in real time. In the midst of the exchanges, a senior astrophysicist at Princeton offered a calm reflection during a conference broadcast. He said, "Science moves forward not when we agree, but when disagreement forces us to refine what we think we know." As discussions continued, research teams formed what journalists began calling scientific courts. Not formal proceedings, but collaborative sessions where groups presented evidence, challenged assumptions, questioned each other's interpretations, and defended their own. Some used detailed hydrodynamic models, showing how extreme internal venting could account for the anomaly. Others displayed reconstructed orbital pathways, illustrating how small observation errors could accumulate into the illusion of non-gravitational forces. Many flashed images, analyses, particle-level simulations, each pixel scrutinized as though it were a witness on the stand. The drama was not theatrical, it was intellectual, yet it carried the tension of a courtroom battle, each scientist fighting not for personal victory but for clarity, for truth, for the privilege of understanding a visitor from another star. Any single misinterpreted measurement could tilt the narrative. Any overlooked variable could shift the conclusion. A mathematician from MIT summarized this tension elegantly when he said in a live stream discussion, "Every pixel matters, every decimal matters. If we get one piece wrong, the whole picture collapses." The drama was not theatrical, it was intellectual, yet it carried the tension of a courtroom battle, each scientist fighting not for personal victory but for clarity, for truth, for the privilege of understanding a visitor from another star. Any single misinterpreted measurement could tilt the narrative. Any overlooked variable could shift the conclusion. But beneath the sharp edges of debate was something softer, a shared sense of wonder. Even those who disagreed with the anomaly's significance admitted that 3I Atlas was unlike anything they had observed before. Comets come and go, their tails shimmer, their cores crack, their paths bend. But interstellar comets are different. They are messengers from worlds we have never seen, shaped by suns we have never known. They carry with them the physics of foreign skies, the chemistry of distant regions, the memory of places our instruments cannot yet reach. They carry with them the physics of foreign skies, the chemistry of distant regions, the memory of places our instruments cannot yet reach. It is easy to assume that scientific debates are hostile, but more often they are acts of devotion. The people arguing the loudest are also the ones who care the most. They argue because the universe has offered them a mystery rare enough to justify every ounce of passion. But beneath the sharp edges of debate was something softer, a shared sense of wonder. Even those who disagreed with the anomaly's significance admitted that 3I Atlas was unlike anything they had observed before. Comets come and go, their tails shimmer, their cores crack, their paths bend. But interstellar comets are different. They are messengers from worlds we have never seen, shaped by suns we have never known. The comet had become a catalyst, pulling the scientific world into a shared struggle for understanding. And in this struggle, every voice mattered, every question mattered, every pixel of light mattered. For that light carried the story of a traveler from another star, and science was determined to hear every word of it. Even if it took 1,000 debates to understand what it meant, the debate surrounding 3I Atlas had reached a fevered pitch. Equations were sharpened like blades. Arguments were exchanged with the careful precision of surgeons. And though no consensus had yet formed, the energy within the scientific community was unmistakable. It was the energy that comes not from confusion, but from possibility. The kind of possibility that pulls researchers into late nights and early mornings, driven by the sense that something extraordinary lies just out of reach. And then, amid the arguments and counter-arguments, another thread emerged. Soft at first, almost overlooked. But soon it began to shimmer, with a promise more profound than any theoretical debate. A thread that carried within it the potential for direct evidence, for chemical truth, for the kind of revelation no argument could dismiss. The debate surrounding 3I Atlas had reached a fevered pitch. Equations were sharpened like blades. Arguments were exchanged with the careful precision of surgeons. And though no consensus had yet formed, the energy within the scientific community was unmistakable. It was the energy that comes not from confusion, but from possibility. The kind of possibility that pulls researchers into late nights and early mornings, driven by the sense that something extraordinary lies just out of reach. The debate surrounding 3I Atlas had reached a fevered pitch. Equations were sharpened like blades. Arguments were exchanged with the careful precision of surgeons. And though no consensus had yet formed, the energy within the scientific community was unmistakable. It was the energy that comes not from confusion, but from possibility. The kind of possibility that pulls researchers into late nights and early mornings, driven by the sense that something extraordinary lies just out of reach. The debate surrounding 3I Atlas had reached a fevered pitch. Equations were sharpened like blades. Arguments were exchanged with the careful precision of surgeons, and though no consensus had yet formed, the energy within the scientific community was unmistakable. It was the energy that comes not from confusion, but from possibility. The kind of possibility that pulls researchers into late nights and early mornings, driven by the sense that something extraordinary lies just out of reach. And then, amid the arguments and counter-arguments, another thread emerged. Soft at first, almost overlooked. But soon it began to shimmer, with a promise more profound than any theoretical debate. A thread that carried within it the potential for direct evidence, for chemical truth, for the kind of revelation no argument could dismiss. And then, amid the arguments and counter-arguments, another thread emerged. Soft at first, almost overlooked. But soon it began to shimmer, with a promise more profound than any theoretical debate. A thread that carried within it the potential for direct evidence, for chemical truth, for the kind of revelation no argument could dismiss. The possibility that Hera and Europa Clipper had flown through the outskirts of 3i Atlas's tail. And then, amid the arguments and counter-arguments, another thread emerged. Soft at first, almost overlooked. But soon it began to shimmer, with a promise more profound than any theoretical debate. A thread that carried within it the potential for direct evidence, for chemical truth, for the kind of revelation no argument could dismiss. But what mattered was not the encounter itself. What mattered was the senses. And then, amid the arguments and counter-arguments, another thread emerged. Soft at first, almost overlooked. But soon it began to shimmer, with a promise more profound than any theoretical debate. A thread that carried within it the potential for direct evidence, for chemical truth, for the kind of revelation no argument could dismiss. But what mattered was not the encounter itself. What mattered was the senses. And then, amid the arguments and counter-arguments, another thread emerged. Soft at first, almost overlooked. But soon it began to shimmer, with a promise more profound than any theoretical debate. A thread that carried within it the potential for direct evidence, for chemical truth, for the kind of revelation no argument could dismiss. A researcher at ESA expressed the significance with a hushed reverence when the idea first surfaced. If the instruments caught even a few particles, he said, we would be holding material from another solar system, not observing it, holding it. The idea electrified the scientific community. For decades, astronomers have dreamed of studying interstellar material directly. Starlight can reveal some of its properties, and telescopes can infer others. But to physically sample it, to touch it through the senses of our instruments, is something else entirely. It is the difference between hearing about a distant world and holding a grain of its soil. Hera's dust detectors and plasma analyzers are sensitive enough to register microscopic impacts. Europa Clipper's instruments can capture charged particles with remarkable precision. If either spacecraft had passed through the faint outer shell of the ion tail, the data would be waiting quietly in their archives, unsuspecting of its own importance, which meant the next step was clear. The stored sensor data had to be retrieved, examined, decoded. Engineers began pulling telemetry logs. Scientists requested time-stamped readings. Cross-referencing began to determine whether the spacecraft trajectories overlapped with the comet's expanding plume of ionized gas at the crucial moment. This process was not dramatic. There were no sudden gasps in control rooms, no glowing images appearing on screens. Instead, it was a slow unraveling of possibility, guided by timestamps, orbital calculations, and sensor logs that read like the heartbeat of machines drifting through space, which meant the next step was clear. The stored sensor data had to be retrieved, examined, decoded. Engineers began pulling telemetry logs. Scientists requested time-stamped readings. Cross-referencing began to determine whether the spacecraft trajectories overlapped with the comet's expanding plume of ionized gas at the crucial moment. For if the spacecraft had indeed captured interstellar material, even in the tiniest quantities, those particles could reveal something the debates on Earth could not. They could show the chemical composition of 3I Atlas directly, without the distortions of distance, brightness, or perspective. They could confirm whether the comet carried supervolatiles never seen in our system. They could show isotopic ratios that pointed to another star's chemistry. They could reveal whether the comet's unusual behavior was rooted in its alien origin. They could reveal whether the comet's unusual behavior was rooted in its alien origin. And that was perhaps the most astonishing part. These spacecraft had not gone searching for the comet. They had not been directed toward it. They had simply been where they already needed to be. The encounter, if confirmed, would be pure coincidence. But in astronomy, coincidence is often indistinguishable from destiny. The universe arranges its paths, and sometimes those paths cross in ways no human plan could predict. For if the spacecraft had indeed captured interstellar material, even in the tiniest quantities, those particles could reveal something the debates on Earth could not. They could show the chemical composition of 3I Atlas directly, without the distortions of distance, brightness, or perspective. They could confirm whether the comet carried supervolatiles never seen in our system. They could show isotopic ratios that pointed to another star's chemistry. The world began to watch, not with the urgency of breaking news, but with the quiet breath of collective curiosity, because the truth stored inside those sensor logs, still sleeping in digital archives, might answer one of the oldest questions humanity has ever asked. In those waiting days, humanity stood at a threshold, not because a comet had glowed brighter or shifted path, but because two silent spacecraft might have unknowingly carried home a message written in the dust of another star. In those waiting days, humanity stood at a threshold, not because a comet had glowed brighter or shifted path, but because two silent spacecraft might have unknowingly carried home a message written in the dust of another star. The world waited, not for an argument, for an answer. The possibility that Hera and Europa Clipper had brushed through the outer breath of 3I Atlas sent a tremor through the scientific world. It felt like the quiet turning of a cosmic key, as if the universe had decided to reveal a little more than we expected, and a little earlier than we were prepared for. Engineers began pulling data. Chemists sharpened their tools. Astronomers held their breath, waiting for signatures that might rewrite entire chapters of planetary science. But even before those spacecraft logs could be fully analyzed, another wave of revelations arrived from Earth-based observatories. These were not dramatic discoveries delivered in a single moment. They came slowly, piece by piece, like fragments of a portrait assembling into clarity. And as the pieces aligned, a new understanding began to take shape. Not about the comet's behavior, not about its brightness or its shifting orbit, but about its identity. The world waited, not for an argument, for an answer. When the first spectroscopic analyses were completed, scientists were astonished. 3I Atlas was unlike any comet routinely observed in our solar system. Its composition was not simply unusual, it was extreme. The levels of supervolatile ices, including carbon monoxide, carbon dioxide, and methane, were far higher than predicted. These substances evaporate at very low temperatures, meaning they do not survive long in regions close to a star. And yet this comet contained them in abundance, locked away for ages until the sun's heat ignited them. This realization deepened the sense of wonder surrounding the comet. If the polarization signature matched Kuiper belt bodies but the chemical composition exceeded their volatility, then 3I Atlas might have originated in a region analogous to the outermost edges of another star system, a place where sunlight is a distant whisper and temperatures sink so low that even the most delicate ices can remain intact for billions of years. Those volatile, rich layers explained much of what had puzzled astronomers earlier. The violent outgassing, the rapid brightening, the dramatic acceleration as jets of escaping gas pushed against the nucleus. But the deeper implications stretched far beyond the physics of a single encounter. For such ices to remain preserved, the comet must have formed in an extraordinarily cold environment, colder even than the outskirts of our own solar system, colder than regions where Kuiper belt objects originate, colder perhaps than anything we have directly studied before. and the composition was only the first clue. As light scattered off the dust surrounding the comet, telescopes measured its polarization signature. Light can carry the shape of the particles it touches. It bends and tilts in ways that reveal the texture and size of the grains. This polarization pattern, once decoded, resembles a fingerprint. And the fingerprint of 3I Atlas matched something familiar, yet distant. It resembled not the comets of our inner solar system, but the icy bodies orbiting beyond Neptune. Objects like Pluto, objects formed in the frozen frontier of the Kuiper Belt. This process was not dramatic. There were no sudden gasps in control rooms, no glowing images appearing on screens. Instead, it was a slow unraveling of possibility, guided by timestamps, orbital calculations, and sensor logs that read like the heartbeat of machines drifting through space. For such ices to remain preserved, the comet must have formed in an extraordinarily cold environment, colder even than the outskirts of our own solar system, colder than regions where Kuiper Belt objects originate, colder perhaps than anything we have directly studied before. And the composition was only the first clue. The result was explosive outgassing, irregular jets, and a rapid reshaping of the comet's appearance. As it neared the Sunday, a planetary scientist at the European Southern Observatory summarized the idea during a press briefing. "What we are seeing," she said, "is the signature of a world beyond another Sunday. It is the chemistry of a distant dawn." One researcher from Harvard expressed the idea with awe during a conference. "This comet is primordial," he said. "It is a piece of a world that existed long before our sun was born." The more scientists studied the data, the clearer the portrait became. 3I Atlas was not simply unusual, it was ancient in a way that defied ordinary language. Formed in a region so cold, so distant, that even time itself seemed to move more slowly there. Shaped by processes entirely foreign to the environment of our inner solar system. Preserved by the deep freeze of interstellar space during its long journey between stars. A planetary scientist at the European Southern Observatory summarized the idea during a press briefing. "What we are seeing," she said, "is the signature of a world beyond another Sunday. It is the chemistry of a distant dawn." The comet's structure, composition, and thermal behavior painted the image of a world in perpetual twilight, where methane frostcoats mountains, where carbon monoxide vapor lies beneath ancient crusts, where sunlight takes hours to warm even the uppermost layers of ice. Its core, fragile and riddled with cavities, behaved like a reservoir of ancient material. When heated, those layers responded not delicately but dramatically. The comet was not merely an icy traveler, it was an archive, a frozen record of conditions at the far edge of a planetary system we will never see. Astrobiologists watched the results with a kind of reverent fascination. These were not the building blocks of life on Earth alone. They were universal ingredients, scattered throughout the cosmos in quiet abundance. And now, they were traveling past our sun, carried by a fragment from another sky. A senior scientist at NASA's Jet Propulsion Laboratory put it plainly in an interview. "We are looking," she said, "at the earliest material from another solar system. This is cosmic archaeology." Her words resonated across communities of researchers. For 3I Atlas was not simply a comet. It was a piece of cosmic history, older than our world, older perhaps than our star, carrying within its fragile structure the memory of an alien dawn. As the comet continued its outward journey, fading slowly into the distance, the scientific world felt a quiet shift. The excitement of debate, the thrill of discovery, the mystery of unexpected behavior, all of it began to settle into something deeper, a sense of connection. 3I Atlas had crossed the gulf between stars carrying a story written in ice and dust. A story forged in a place we will never visit. A story older than any human civilization. And by passing briefly through our sky, it allowed us to read a fragment of that story, to touch, through instruments and light, the memory of another world. It reminded us that the universe is not just vast, it is connected, that the boundaries between star systems are not walls, but long, silent bridges. And every so often, A traveler crosses one of those bridges and enters our sky carrying secrets only ice can hold. In that sense, the nature of 3I Atlas was not merely scientific. It was poetic. It was ancestral. It was the whisper of another sun carried across interstellar night. When scientists finally pieced together the portrait of 3I Atlas, when they saw its volatile chemistry, its porous body, its layered memory of a sun that was not ours, a certain quietness settled over the community. It was the quiet that arrives not at the end of discovery, but at the beginning of realization. A researcher at the University of Michigan, reviewing the measurements, exhaled softly before saying, "This thing is loaded with volatiles. It is practically a cryogenic relic." And with that understanding came another. 3I Atlas was not the first such messenger. This realization guides us gently into Chapter 10. This realization guides us gently into Chapter 10. To understand the third, one must remember the first and second. And with that understanding came another. 3I Atlas was not the first such messenger. Its motion deviated slightly from pure gravity, hinting at faint outgassing that no telescope could detect. It left astronomers with equations that folded back on themselves, resisting closure. The first was 1I Oumuamua. It flashed into our solar system in 2017 like a stone skipping across a pond, fast, silent, and deeply confusing. It had no tail, no envelope of gas, no icy coma. It did not behave like a comet, nor did it resemble any asteroid humanity had ever catalogued. Its brightness flickered strangely, suggesting a long, tumbling shape. Some models described it as cigar-like, others as pancake-thin. To this day, Oumuamua remains a mystery. Was it frozen nitrogen from a Pluto-like world, a fragment of a tidally torn planetesimal, a shard of something stranger? The questions still hang in the air. 2 years later came 2I Borisov. Unlike its predecessor, Borisov was familiar, comfortingly so. It behaved like a classic comet from our own solar system, trailing dust, releasing gas, brightening under sunlight. Its composition leaned heavily toward carbon monoxide, more than typical local comets, but still within reason. It was, by all accounts, a normal icy traveler that happened to be born around another star. Scientists felt, perhaps for the first time, a sense of relief. Interstellar visitors, it seemed, could be ordinary. A researcher at the Max Planck Institute summarized the sentiment simply during a conference. Borisov is the kind of comet we expected to see. The surprise is that it is not surprising. Then came 3I Atlas, where Oumuamua was silent and strange, and Borisov was familiar and predictable. Atlas arrived like a storm. It came with volatile, rich ice that erupted under sunlight. It changed shape after perihelion. It brightened by factors no model anticipated. It shed mass so rapidly that its own orbit bent under the force of its escaping gases. It carried the thermal signature and polarization imprint of a world shaped in a deeper, colder cradle than anything in our own system. If Oumuamua was enigmatic and Borisov was comforting, Atlas was wild. This contrast reshaped the way scientists thought about interstellar objects. No longer could they imagine them as distant cousins of our local comets. They were beginning to look like ambassadors, each one delivering a piece of its home star system, a sample of the chemistry, structure, and cosmic history written in the outer reaches of other suns. One scientist at NASA expressed this realization beautifully during a roundtable discussion. Each of these objects is a message, and every message is written in a different language. The comparison between the 3 interstellar travelers revealed something profound, not about them, but about the universe itself. It told us that solar systems are not uniform. They do not produce identical comets or planets or asteroid belts. They sculpt their objects from different ices, atmospheres, temperatures, radiation fields, and histories. The diversity we see among local comets is only a fraction of the diversity that exists across the galaxy. If Oumuamua was enigmatic and Borisov was comforting, Atlas was wild. Each object carried a different culture of ice, A different childhood shaped by its native star, a different memory etched into its surface and core. One scientist at NASA expressed this realization beautifully during a roundtable discussion. Each of these objects is a message, and every message is written in a different language. The more scientists looked at the trio, the more they realized that each had forced them to recalibrate their understanding. Oumuamua made them question what shapes interstellar objects could have. Borisov confirmed that comets from other stars could look much like our own. Atlas forced them to acknowledge that volatility, structure, and behavior could vary so dramatically that familiar assumptions would fail. Astronomers began to speak of these objects not as anomalies, but as storytellers. The universe was not sending repetitions, it was sending chapters. And each visitor offered insight into the environments where stars are born, where planets form, where icy bodies accumulate and freeze and fracture. The great revelation of Chapter 10 was this. A researcher at the Max Planck Institute summarized the sentiment simply during a conference. Borisov is the kind of comet we expected to see. The surprise is that it is not surprising. 3 interstellar guests, 3 personalities, 3 messages written in trajectories and light. A professor from Caltech phrased it with quiet admiration during an interview. The galaxy is not sending duplicates, it is sending originals. That idea resonated deeply. 3 interstellar guests, 3 personalities, 3 messages written in trajectories and light. 3I Atlas was the latest chapter in that cosmic anthology. A wild traveler bearing the imprint of an extreme frontier, a fragment of a world built on cold and pressure and darkness so deep it preserves molecules for billions of years. And as the comet drifted farther from the sun, its tail fading into a long whisper of blue and white, scientists felt something they rarely admit: gratitude. For in its brief passage through our sky, Atlas had shown us that we are part of something larger than we can fully imagine. It reminded us that beyond our sun, beyond our planets, beyond everything we know, there are worlds that carve their own stories into the ice. Stories that sometimes travel across the dark to find us. The universe does not repeat itself. It creates endlessly, and every interstellar visitor is proof. As 3I Atlas drifts back into the quiet beyond our sun, its light thins into a memory. You can almost feel that distance settling, like a final breath before the darkness closes in again. And for a moment, the sky feels larger than it did before. Not louder, not brighter, just deeper. A place where questions echo longer than answers, where mysteries move at the pace of eternity. And as the comet drifted farther from the sun, its tail fading into a long whisper of blue and white, scientists felt something they rarely admit. Astronomers began to speak of these objects not as anomalies, but as storytellers. The universe was not sending repetitions, it was sending chapters. And each visitor offered insight into the environments where stars are born, where planets form, where icy bodies accumulate and freeze and fracture. And as we let it fade, we carry something forward, a sense that our curiosity is not a burden, but a compass, a sense that even in the vastness, we are allowed to keep asking. So if tonight's story stirred something quiet in you, if it opened a window into the kind of wonder that only arrives at the edge of sleep, I invite you to stay with us. Not out of obligation, not because you should, but because this journey through the dark is gentler when we walk it together. Here, the stories will keep coming, the skies will keep unfolding, and there will always be another mystery waiting just beyond the next breath. And as we let it fade, we carry something forward, a sense that our curiosity is not a burden, but a compass, a sense that even in the vastness, we are allowed to keep asking.